Hello and welcome to the ASDRP Researcher Interview Series. Tonight I'll be talking with Varsha Vijay. Thank you so much for joining me. How are you doing tonight?
I'm doing good. How are you?
I'm doing well, thank you. To start us off, will you tell me a little bit about yourself, what high school you go to, and some of your hobbies, things like that?
I'm in 12th grade. Some of my hobbies, outside of ASDRP, I like reading and drawing and hanging out with my friends.
Awesome. What high school do you go to?
Oh, I go to Cupertino High School.
Nice. And how long have you been researching at ASDRP?
I think 3 or 4 of the sessions.
Okay, nice. So almost 2 years.
Mm.
That's awesome.
Yeah.
And what research group are you a part of?
I'm part of Yamamoto's biomaterial research group.
Awesome. How did you decide to join that group?
I was looking through the projects on the ASDR website, and originally the project that I was most interested in was like a cancer drug creation group. That one is currently disbanded because I think we were like reaching too far for what we knew how to do. So I kind of turned to something not like less important, but less of a stretch goal, kind of like. So that's how I ended up in like the group I am right now. Which is, oh, I didn't mention, we're working on like modifying photo curing hydrogel so it can like properly encapsulate cells and potentially be used for like healing agents or like a surgical glue.
That's awesome. That sounds really interesting. How are you studying the hydrogel? What are some of the, do you work in the lab? What are some of the procedures that you do?
I'm mostly responsible for the cells, so the biology aspects. So I'm mostly doing cell culturing, and we're trying to make our cells secrete insulin, which could be like one of the uses for our hydrogel. If they have insulin secreting cells, that could be like used to distribute insulin to the body. So we're trying to transfect into the cells, and we're using CHO cells right now so that they can secrete insulin. And then we're going to put them into a hydrogel and kind of test how they survive in it, basically. So right now, most of the time I am in the cell culturing room. Sometimes we're also in like the bacteria area, because we do have to like to get the cells to secrete the insulin, we do need to transfect into them. And to get the DNA to do that, we have to purify it from E. coli that we have.
Wow, that sounds like a really fascinating and involved process. It's a really cool material. It sounds like it has a lot of important applications. What is transfecting, and what does that mean?
So transfecting is when you take DNA from like an outside source and you kind of put it into the cell and hope it incorporates into the cell's DNA so that it does different things or modifies it.
Oh, okay, I see. Interesting. Um, what has been a challenge that you've encountered so far in your research?
I think our biggest challenge is the DNA purification itself, because when you purify the DNA from the plasmid, you don't only get the specific sequence of DNA that you're looking for, or the specific plasmid that you're looking for. You also get like a lot of extra DNA that is from like the E. coli for it to do its E. coli thing. So we were going through processes to try to purify the plasmid DNA that we're looking for from the extra DNA. That was a challenge because it wasn't going too well. The DNA was degrading. So we're trying a different method now, just transfecting with the, I guess, unpurified DNA and weeding out the cells that don't have it incorporated afterwards.
Okay. Yeah, wow, that sounds like a really challenging process, especially with DNA. Is DNA delicate to work with?
Like if you like vortex it, it can break up, but it has like a really long shelf life, so we're not worried about that as much. So like yes and no.
Okay, cool. Um, Other than a challenge, what has been something that's been the most rewarding about the project that you're working on?
I really like working with cells and like the cell culture hood. That's like I find it really fun. It's kind of methodical sometimes, but um like the other day, like all of my cells died, but like it happened, but it was really interesting because I think the problem I had with it was that like I overgrew them, so they were like overcrowded, so that's why they died. They like decided that because there are so many of them, they didn't need to grow anymore. So I think like the intricacies of that is really fun to learn about and to deal with.
Absolutely. It's like its own little life. Do you grow them in a petri dish, or how do you take care of your cells?
So I'm using like CHO cells right now, which are hamster cells. So they're just in like a flask with their media just growing in the liquid culture.
Okay, nice. Um, so what's next for your project? What are you going to be working on for the rest of the semester?
Um, well, right now we have some test hydrogels, which are like not the end goal that we want. We want it to be a photo curing hydrogel, which it would be basically be you have the hydrogel like fluid, and then you insert the cell media into the mixture, and then you kind of cure it to solidify it. So right now we have a hydrogel that isn't photo curing. So it's pre-made, and then we're going to try to insert the cells that we have into it and see how they survive and interact with the hydrogel, because we believe that if we put the cells into the hydrogel, they might not like survive as well and be as viable as they would in the media. So want to see how we can like maybe modify the hydrogel to do that, but that's going to be our first testing that we're going to do.
Awesome. Good luck with that. I hope it's successful. So what is it like working with your lab group? How collaborative is it, and what is it like day to day working with them?
Um, I think we've definitely gotten more collaborative. We used to be kind of split almost between the people who were working on like the hydrogel aspect and people who were working on the cell culture aspect, because they're both like pretty big components and that aren't like necessarily intertwined until later. But now we've been kind of, I guess, intermingling almost. So I think I'm learning a lot more too. And
Okay, awesome. So it's two different groups coming together in a way.
kind of, yeah.
Okay. Nice. Um, do you feel as though your research has changed anything about the way that you view the world?
Um, I think like cell culturing specifically, like the little like all the interactions that happen inside there, and I think it'll be like even more so when we incorporate it with the hydrogel, because they are like interacting with like the world around it in different ways. I feel like that's really interesting. I don't think if it's like changed my worldview per se, but it has given me like further insight maybe.
Definitely. That makes sense. Well, for my last question tonight, I would love to know what advice you would give to a future researcher looking to join ASDRP.
Um, Definitely talk with your teammates a lot. They're like your best resource almost, like along with your advisor. Um, it definitely helps learning if you work with your team. And like as I said before, now that we're all like kind of joined, we have like a lot more like brains to work together, obviously, and just a lot more collaboration. It feels like a good group. It's a good supportive community almost.
That's great. That's some great advice. Definitely working with the team is so helpful for the support it provides, and also for what you mentioned with the knowledge, bringing it all together. Well, thank you so much for joining me tonight. It was so great to talk to you and learn more about your research, and good luck with school and ASCRP.
Thank you so much. Have a good night too.